All right, let's see. See, there are 10 of you guys with us today. Great, thank you for coming. Again, my name is David Green. I am an engineer at Ancortek, and today we're going to be giving kind of an introductory presentation on who we are, Ancortek as a company, and what we make and sell, and that's software-defined radars. We're going to give a little talk on their applications and such as well. Elizabeth Wang is the organizer for this. She's also in the staff section. If you need to send her any messages or email her, her email address is listed below. And let's go ahead and get started. So, so as I said before, we're going to cover who we are as a company, the products and services we offer. I'm going to go ahead and give you guys a live demonstration of one of our software-defined radars that we have set up here in the lab. And we're going to go over some applications that we've received from customers, different customer requests, as well as potential applications that these radars could be used for. Finally, we're going to wrap it up with some questions and answers that you guys have. Just as a note, if you can, I guess, hold all your questions until the end, and then we'll go through and we'll answer them one by one. All right. Oh, you know what? Is it not showing my screen? There we go. Okay. Okay. Sorry about that. Not sure how much you missed, but there's the intro slide and there's our overview slide. Okay, so let's talk about Ancortek. We're currently located in beautiful Fairfax, Virginia. It's pretty cold outside right now. It's in the 40s. But we were founded in 2013 by Dr. Victor Chen. He's spent nearly 20 years at the U.S. Naval Research Laboratory under the Radar Division. He's authored multiple books, journals, and proceedings on inverse SAR and micro Doppler analysis. And in 2007, he was elected by IEEE to be a fellow, being recognized for contributions to time frequency analysis and for radar imaging and target feature extraction. So this guy really knows his stuff. He's assembled a multidisciplinary engineering team. We've got all our bases covered as far as FPGA development, hardware development, software development, radar signal processing, you name it, we can just about do it. And we have a global presence. We're selling all over the world, Turkey, just in various countries, and we've worked that all out. So moving on, what we do, Ancortek is a company. We develop RF and processing module boards that can be used for software-defined radar. So the processing board is on the top here, and one of our RF modules is on the bottom. These boards are lightweight and low-powered. They provide real-time operation for radar applications, and they can be used for a variety of different applications. They can be repurposed very quickly and on demand. We provide a very simple data interfacing technique that's all run through USB. And then these devices have single and dual receive channels for just a variety of different applications. So just the basic overview for these radars. These are continuous wave software-defined radars. So what that means is that starting at the top in our RF module, we have a PLL and a VCO, and that's attached to an amplifier, and we send that waveform out, and that's going to be our carrier modulated with whatever signal we're working with. So whether it's a ramp signal or FSK, those will all that'll be sent out. When we receive the signal, we do a little bit of filtering, and then we mix it with a copy of our transmitted signal. After that's been mixed, we look at that product, and that's sampled down here by our processing modules. And that includes, let me see if I can grab this here, yeah. Okay, so that includes our ADCs. This is one of the advanced processing modules, so it has 4 ADCs, 2 for each channel. And that's all processed by our FPGA, and then we send that out over USB, the raw INQ samples, so that you can use it for whatever application you have in mind. And then this is on the right. It's just an example. We've attached one of the radars to a SAR rail platform in the lab. All right. So some of the benefits that we have of our radars is that we've spent a lot of time and a lot of work on really minimizing these radars down to a single small embedded package. They're highly integrated. They're very low power, very small, and very lightweight. That means that you can mount them on drones. You can place them in remote areas. They can be battery powered for long durations of time. If you want to do long-term outdoor collections, we provide that to you. They're great for rapid prototyping and concept development. So if you have an idea or maybe a different application that could use a radar, it's very simple to just drop our radar in and start collecting data or start processing data. We provide not only the hardware but the software interfaces for you to do that. And because it's software defined, you have complete control over the operational modes of the radar, the waveforms, the bandwidth, sweep time, just to name a few. You're in control of that. It's all done via software processing in that manner. And then the benefits of software-defined radar is that radar can operate in harsh weather and in all different kinds of lighting conditions. So, for example, if you're looking at security applications where you need to see subjects, cameras can get foggy or dusty or dirty. If there's poor lighting condition, you won't be able to see people. But radar can operate through dust, through rain. And it needs no light, so they operate in all different kinds of conditions, and they're really great for that. They provide a non-contact and non-invasive sensing technique. So, for example, you can mount them in the corner of a room or on a ceiling and monitor the presence of people in a room without having to attach anything to them. Or if you want to monitor heart rate or respiration rate, you don't have to attach a probe or anything to the actual patient. You can do all that remotely. We also offer really great ground and wall penetration capabilities, particularly at our 5.8 gigahertz band. So if you want to see through a variety of different walls or mediums, you can go ahead and do that. And then also for ground penetration. And then our software API, we include lots of different examples to go ahead and just start measuring range, velocity, angle of arrival, things like that, right out of the box. As soon as you receive the product, you can go ahead and start doing those things. So to actually use our radar, we provide a number of, there's a number of different roads that you can use right now to go ahead and start using it. The first one is through the graphical user interface. So we call this the SDR GUI. And it runs in both Windows and on MATLAB. And you can think of it as just a very user-friendly control panel. I'll give you a demonstration of this right after, but basically you have real-time control over all the different operating parameters of the radar. You can do additional filtering or clutter suppression, imaging, all of those different things. It's really a demonstrational tool for the radar itself. And then it also provides a very simplistic data collection mechanism. So if you don't want to go through the hassle of developing your own program, you can go ahead and use the GUI to just collect samples of data and process that in MATLAB or in whatever other tool, whether it's Python or R that you use. So along with the GUI, we provide a set of APIs. They run in both Linux and Windows, and these APIs are basically libraries for integrating the radar into applications that use C++ or MATLAB. So if you're working on an application for a car and it's written in C++, we provide basically a library so that you can drag and drop the radar into your application, or develop an application around our radars and use our radars very easily. We've taken a lot of the heavy lifting out of that and provided a very simple library to go ahead and use. And then we also do customizable firmware on request. So if you want the FPGA to do particular processing techniques or things of those nature, we can make all of that available for you and do those customizations for you. So we'll go over some of the products and services that we have. The first one is our basic product lineup. So these are all single transmit, single receive boards. They vary from 2.4 gigahertz all the way up to 24 gigahertz. And on the lower end units, the 2.4 and the 9.8 gigahertz model, we offer 400 megahertz of bandwidth. And it's adjustable. You can adjust it from, I believe it's 100, 150 megahertz, all the way up to 400 megahertz. The 24 gigahertz model has 2 gigahertz of bandwidth that you can use at your disposal. They all come with a variety of different antennas depending on the center frequency. So for example, the 2.4 gigahertz, switch back over here to the spotlight, the 2.4 gigahertz one will come with horn antennas because that's more appropriate for the carrier or the center frequency that it's using, whereas the 9.8 and then the 2.4 will have these larger patch antennas. Get back here. So our advanced product lineup, essentially the main difference is that we've added an additional phase lock loop and some other stuff to the RF module, which provides a cleaner transmit waveform. And so we have 2 different center frequencies that these operate at. One is the 5.8 gigahertz model, the 580 AD, and that has a bandwidth from 400 to 800 megahertz. And then our 2400 AD and 82 is centered at 24 gigahertz, whereas where the 82 has two receive channels. You have two coherent receive channels that you can use for things such as time of arrival or angle estimation, or radar interferometry. You can do all those things with those two receive channels. And so when you get a kit from us, basically what it includes is that you have the FPGA processing module, and it'll have either 2 or 4 receive channels, whether it's a basic or an advanced board. You'll have the RF module itself, and that's going to range from 2.4 to 24 gigahertz. You'll have all of the software that we have available, which includes the GUIs for MATLAB and Windows, as well as the API libraries for C++ and MATLAB so that you can develop your own applications. And then we include all the power and USB and RF cabling connectivity that you need to go ahead and to set this thing up and hit the ground running. You can start collecting data as soon as you receive it. So along with products, we also offer a number of different services. The first one is that we can fully customize our products for you. So if you need modifications done to the transmitter receive chain, additional filtering, amplification, things like that, we can make all those hardware modifications in-house. We can adapt the processing module board in any particular way that fits your application, whether that's adjusting the FPGA code or working on different, maybe expanding memory, things like that. We're more than happy to do that. As well as, maybe you need a completely new radar dropped into your application. We do complete custom application integration. All of those are available to you. We also focus heavily on research and development, and so just as an example, one of our partners is Infineon Technologies, and we are just recently started working with them on doing occupancy sensing. So we're generally detecting people in a room and things of that nature, and we're going to be at CES 2017 in Las Vegas. And then just to tap on it again, we have a multidisciplinary engineering team basically at the customer's disposal. So we can tackle a wide variety of problems. We've worked on a wide variety of problems, and we're here to support our customers. So let's start out with a demonstration using the Windows GUI. And if you can bear with me for 1 second, let me go ahead and get the webcam set up or turned on. Okay, great. So here with me I have the 2482 module, and I've taken the case off of the top so that you can see the insides, specifically before when I was saying that you have the RF processing module on the top here, as well as the FPGA processing board on the bottom. I've gone ahead and connected a 24 gigahertz horn antenna to the transmit line and to the receive, and I have tapped out the second receive channel on this device. We're just going to look at the first receive channel. And so let me switch my screen over to the GUI. So when the GUI starts up, it's going to let you know that nothing's available. This is the Windows GUI here. And so what I'll do is I'll connect it over USB. Your power light will come on up at the top. We can refresh, and it sees an Ancortek USB device. We'll go ahead and activate. And when you first start the program and you activate it, it's going to load default set of parameters. So it's going to start out in FMCW sawtooth mode with 500 megahertz of bandwidth, 128 samples per sweep, and a millisecond per sweep. And it's looking at range and time at first. So on the top, we have a time plot. This is basically each sweep, the real-time samples that we're getting back from the device. And then on the bottom, this is post-range processing. And we can adjust all these parameters on the fly. So if we want to switch into FSK mode, or if we want to look at CW, we can do all of this in real time. And as we change this, it's changing the parameters on the FPGA processing module here and adjusting the RF front end and all of that. We can adjust the bandwidth. So if we want to go from 500 to 2 gigahertz or 500 megahertz to 2 gigahertz bandwidth, we can do that. We can adjust the samples per sweep, essentially adding granularity to our sweeps there. And then we can adjust the sweep time, so essentially how long each of the sweeps is. And this is from 1 millisecond up to 10 milliseconds. We can look at, right now it's defaulting to range and time scope, but we can look at a velocity scope. So for there's a parameter later on to adjust how many sweeps we look at per Doppler processing. So right now it's plotting all of them up at the top, and then it's looking at the velocity at the bottom, and it's going to go ahead and track the largest power return that we get. So if I take my hand and I cover the antennas and I start moving up and down, you can see that as I move towards it, I'm coming back towards it now, it's going to stay on the left side of that Doppler plot. Let me see if I can get the spotlight here. So it's going to stay on the left side, and as I move away from it, it's going to show up on the right side here. And then as I move faster, I'm going to move more quickly or farther away from that center line. I'm not sure how quickly it's updating for you guys remotely, but yeah, so that's what's going on. And then we can do, let me switch back to the mouse. We can look at range and velocity maps, and for this to look good, what we're going to do is we're going to do some quick filtering. So we already have a DC subtraction set up and a Hamming window for our FFTs, but I'm going to go ahead and turn on direct clutter cancellation because I'm operating here in an office, so there's, you've got the walls, the desk, me, things like that. And I'm going to do that using just a moving average filter. And you have other features here as well. You can window out specific ranges or velocity. You can do an outdoor range weighting filter. All that's made available. And so now we also have control over the imaging. So we can set our maximum minimum dynamic range that we want to look at, update rate, how many Doppler sweeps are in there, things like that. So now it's set to automatic for the dynamic range. So as I move my hand back and forth, let me switch back over to Spotlight. This is my hand right here, this large return here. So as I move towards it, I show up on the left. As I move away from it, I show up on the right. And then I can move quicker, and you'll see it start to kind of circle around there. And then this up here is actually my reflection off of the ceiling. It's picking that up too. And so we can come back in here and we can adjust all these things. So if I don't want it operating on a dynamic range or an automatic imaging parameters here, so we can lower that, maybe get rid of some of the noise floor. There you go. Okay, so we can kind of isolate that, my hand there, get rid of some of the noise in the background. All right, and then we can also do things like a range waterfall plot. And let me go back over here and adjust that down maybe. There we go. Okay, so I'm just playing around with the dynamic range for what's being imaged, and I'm waving my hand back and forth, and so you can see that left wiggly line. That's me going back and forth there, and I can change the display rate too. So it's updating every 100 milliseconds. I can drop this down to 20, and so it updates much faster. And so you can see that happen there. All right, so aside from that, we can also export data. And the first thing that we're going to do is we offer exporting the images, or the plots here. So whatever plot you're currently working in, you can switch over to export mode, and you can say, hey, I want to give me a PNG of the bottom plot. And so when I click that, what it'll do is it'll take a snapshot of it, and then I'll just drop it here in output. And let me go ahead and load up my screen for you guys. Okay, so it dropped it into a folder, and I can go ahead and view that image. Likewise, I can also do PDFs. So if I go here and start waving my hand again and say, okay, I want the bottom view, let me drop it into the output folder and save. If I come back over here, it'll generate a PDF, and it's fairly large, but it'll show you exactly what you're seeing in that plot. And so aside from just the images, you can also export the raw INQ samples. So if you say that, hey, I want to do a collection, maybe a 3-second collection, you specify that, it'll automatically determine what the sampling rate is depending on your operating parameters of the radar, and then it'll let you know how many samples you should expect to receive. And so I'll start waving my hand again, and we'll tell it to record data. And when you click record, it's going to ask you where you want to save it. And so we're just going to save it in that same output folder, and it'll name it according to the current date and time on your computer. And it saves it as a .dat file, .dat. So as soon as you click save, it'll go ahead and start your recording process. And you'll see that my window is held up right now. And that's just a visual reminder that, hey, I'm recording all the samples that I receive instead of processing them. And then once it's done, the window will kick back up here. And so we can see if we go back to our output folder here, there's our data file. and it stores it just as a simple text file so that it's really easy to work with it in things like MATLAB. The first four up here are the radar parameters. So we have center frequency, number of samples, per sweep, things like that. And then you have the raw and Q samples. And this goes on, let's see, it said 384,000. So since this is the 82 module that I'm using now, it's got 2 receive chains, it's actually going to go ahead and store from both receive chains. So it does, channel 1, channel 2, channel 1, channel 2, back and forth. So we get all that, and then we can, load up MATLAB and process this data for whatever, fits our application. We've also added some camera controls. So if you have an attached webcam, you can load that up and it'll show it as an additional window. So if you want to do image exports or things like that, and you want to be able to see what the radar's looking at, this is really good for if you have it set up somewhere remote, or if it's up on the top of a pole or something like that. We found that pretty useful. So yeah, so that's the SDR GUI, and you can really dig into this. We have a lot more features with FSK and CW mode as well, and different filtering that you can play around with. And again, this is available both in Windows and in MATLAB. So let me go ahead and close this out, and we'll jump back into the presentation. All right. So let's talk about the different applications for these radars. So to start with, we were going to talk about, or I want to mention some of the actual requests that we've received from customers. So the first one I talked about before, that was with Infineon. And they're looking at occupancy sensing. So essentially, we can place the radar in the corner of our room, or somewhere off to the distance, and we can monitor whether or not there are people in that room. And that's doing things. You can look at motion, you can look at respiratory rate, things like that, to try to figure out if there's someone present in that room or not. We've looked at radar gesture detection. So if you've heard of Google Soleil project and what they're doing with their multi-channel receivers, how they can detect hand motion, body part motion, things like that, you can do all of that with our radars as well. And you can also look at cardio and respiratory monitoring. So if you want to find out, what's a patient's heart rate or what's their breathing rate or things like that, you can do all of that with our radars. We've done some through-wall sensing applications where you can have the radar set up to look through office walls, look through building walls, a variety of different mediums, and figure out, are there people moving on the other side? Can we try to localize them? Those types of applications. And then also the radars are very, as I said before, very light and low powered, so you can mount them onto UAVs and do SAR imaging applications with the UAV flying around, or on a rail or a track, something along those lines. And then finally, for automotive radar, these things are very applicable to automatic cruise control, collision avoidance, things like that. They can be placed on the front, on the sides, on the top of a car, and you can get all that data back in real time and process it. Some other industrial applications we've had, and that the radars are good for. The first one being radar tank level gauging. This is kind of a classic example, but you place the radar at the top of a tank, and the geometry of this tank, the wall thickness and the size, and then by measuring the distance from the radar to the surface of the fluid that you have in there, you can figure out what the volume of that fluid is. Another application is traffic monitoring. This was actually a pretty cool application that we did. We set the radar up on the side of an apartment building, and we were looking at all of the different cars that were passing by on the street next to it, as well as the pedestrians. And we could figure out, which lanes the cars were in, how quickly they were traveling, what direction they were traveling in, and then the same for the pedestrians. So that was a pretty cool application. Again, as I said before, you can use it for automotive radar systems. So whether it's automatic cruise control, collision avoidance, blind spot detection, backup driving, all of those things, you can place it all over the car. And then we've had some other people that are, as I said before, interested in UAV and SAR imaging. So attaching the radar to the bottom of a drone or a quadricopter or something of that nature, and then flying it around. And you can do FMCW, SAR mode, or all different kinds of things. Also, talking again on the medical applications, it's a really good non-contact and non-invasive tool for collecting data. So you can have the radar set, on a nightstand or on the ceiling or something like that, and you can monitor the sleeping patterns of an individual in their bed, or a patient in their bed if you're using this in a hospital, and you can extract their heartbeat and respiration. For security, it's fantastic. You can use this device for motion detection, and localization, so you can figure out how many people are about in a room, about where they are. Are they running? Are they jumping? Are they standing still? Things like that. And then if you couple that with the through-wall capabilities of the radar, what you end up doing is that on the right we have a picture of that's actually me in a hallway. You can place the radar behind doors or behind drywall, for example, and you can monitor this hallway and figure out, are there people coming down this hallway? How quickly are they walking? Are they jumping? Are they, approaching someone's door? And it's all very useful for security when you want to keep the privacy of the customer in mind. So, for example, the patrons of this hotel or this apartment building, maybe you don't want to set up a camera to reveal their identity and things like that, but you still want to know, hey, is there some activity going on this floor? Radar is a great tool for that, and all of our radars are capable of doing this. And then finally, Dr. Victor Chen's original work of micro-Doppler analysis, that's what these tools were originally aimed to do. So we can look at the micro-Doppler analysis of an individual walking or running, figure out their gait, things like that. And then also for example, for helicopters or these model RC planes, we can figure out, what's the speed of the rotors? How many rotors do they have? Those kinds of applications are all very interesting and possible using our radars. All right, so at this time, I'd like to go ahead and, I guess, figure out if you guys have questions about anything. If you have questions about our company, particular questions about the products that we have, if you just use the raise your hand tool on the right, it should be attached to your window there, and it kind of looks like a hand with an arrow on it. And all right, yes, we've got one now. Let me figure out how to get over here and